Continuing with 2.5, 2.6, it would be part 2, using parentheses when differentiating. Example 3, try these on your own. Find the derivative of each of the following. So we have 4 examples right there. So we have, for part A, we have y equals 3, right? So 3 over 8 would be our constant, times x raised to the 4th power. So again, we're applying the power property, so x raised to the n, right? So that would be y. And then y prime would be n times x to the n minus 1. So here, constants. Now we have a constant, right, which we just saw in the last example. So c equals 3 over 8, and then n equals 4, and minus 1 is equal to 3. So y prime equals the constant 3 over 8 times 4 times x to the n minus 1, which would be 3. And then simplify a little bit further. This is going to be 3 over 2 times x to the 3, and that would be our y prime. In example B, now be careful, because if you notice we have a parenthesis around the 3x, so that means we still have to use the other algebraic properties we learned before, which would be like this distributive property. So this would be equal to 3 raised to the 4th power times x raised to the 4th over 8. So we're looking for y prime, so y prime equals the constants would be 3 to the 4th, which would be 81, and then over 8, right? Remember, you can have a fractional constant. And then n equals 4 and minus 1, again, is 3. So this would be times 4 and then times x to the 3rd power. Simplify the constants, and then you're going to get 81 over 2 times x to the 3rd. And that would be your y prime. On example C, we have y equals 9 over 7 times x squared. So again, your constants, right? Y prime, your constant is the fraction, 9 over 7, times, and then we're going to have, since we have x in the denominator, remember we want to rewrite it as a negative exponent. So this would be x to the negative 2. So n equals negative 2, therefore n minus 1 would be negative 3. And that's x raised to the, I'm sorry, skipping a step here. Let's not forget about negative 2. So negative 2, and then times x to the negative 3. So y prime equals 9 times negative 2, which would be equal to negative 18 over 7, and then x to the negative 3. And then once you, again, remember your answers are always going to have positive exponents, so make sure you rewrite it with a positive exponent. So that's going to be negative 18 over 7x to the 3rd power. And then example 3D actually. So we have y again. We have parentheses, so make sure you distribute that. That's always the simplest way to do this. If you have that type of exponents, we'll see later on another property that actually allows us to not have to use the distributive property, but we still have to learn the basic ones. So here we're again, make sure you distribute the squared first inside the 7x. So 9 over 7 squared, which would be 49x squared. And then this would be, again, your constant is 9 over 49 times x to the, remember to rewrite it with a negative exponent, so x to the negative 2. So y prime equals 9 over 49 are constants, right? Just move it to the front. And then times our n, which is negative 2. And then our n minus 1 is negative 3 here, so x to the negative 3. And then we're almost done. Again, 9 times negative 2 gives us negative 18. And then over 49, rewrite it with a positive exponent, and that would be x to the 3rd power. So that's our y prime. Now we're going to be looking at two more different rules. So the sum and difference rule, and it's pretty much the same thing as we talked about before in limits. Like you can split up the limits. If you have like an x squared plus an x, you can always say the limit of x squared plus the limit of x, right? So it's kind of the same thing with the derivatives, right? The definition of a derivative comes from a limit. So that's pretty much why these rules look kind of the same too. So you just got to be careful, right? Because some of them are do two different things though. So the sum or difference of two differentiable functions is differentiable and is the sum of or difference of their derivatives. So again, if you take the derivative of f of x plus g of x is the same as their separate derivatives, that's the sum, right? And pretty much the same thing for the difference rule, just the signs change. So here we want to find the derivative of each of the following. Now, be careful whenever you guys see these things right here. The first thing you want to do is like make sure you separate all the fractions, like make separate fractions if you see just a single denominator. So this would be x to the third over x minus 4x over x and then plus 5 over x. And then make sure you guys do this primarily because, again, you can simplify a little bit further. So that's going to give us x to the second power and then minus 4 and then plus 5 times x to the negative 1. So here, again, we want to simplify one more time. So that's going to be just our f of x, right? So we haven't even started taking the derivative. So x to the second is our pretty much like our first function, right? So n equals 2 here. Our n minus 1 is going to be just positive 1, right? So that's f prime of x. So the first one is just going to be 2 times x. Okay, we're done. The next one, so we have minus 4, right? So there's an n x to the 0 pretty much right there next to it, right? But the derivative of a constant, remember, is just 0. So this just transfers as a 0, right? Plus 0. And then our last one right here, we have plus 5 times x to the n minus 1. And then again, we have a constant, so that remains the same, right? That one just goes straight down. And then our n is equal to negative 1, and then n minus 1 would be negative 2. So here would be times negative 1 times x to the negative 2. And then to wrap things up, pretty much, we have f prime of x is equal to, we have 2x, and then 5 times negative 1 is negative 5x to the negative 2, and then just rewrite everything with positive exponents. 2x minus 5 over x to the second power. And now we're looking at example B. So again, like I said, later on, there's still going to be like faster ways to do this. For right now, just work out through the algebra. It should be pretty easy to work it out, especially if you guys use the area model to multiply it out, right? So we have x squared plus 1, and then we have x minus 3. So we have x to the third, and then positive x, negative 3x squared, and then negative 3. So that's just our g of x. We haven't even changed it yet. So g of x equals x cubed plus x minus 3x squared, and then minus 3. And now we're looking for g prime. So again, we're going to apply the constant and power rule, which is pretty much the only things we've learned so far. So n equals 3 here. So that's 3 times nx to the n minus 1, which is positive 2. And then the derivative of x is always just going to be positive 1, so plus 1. And then for the next one, we have the constants is negative 3, and then times n, which is positive 2, times x to the first power, right? Take away 1 from there. And then the derivative of a constant is 0, so plus 0. And then again, g prime of x. We simplify one more time, right? We combine any like terms if we have any. We're going to have 3x squared minus 6x plus 1. So again, the key here is still applying, right, the power rule, the power and constant rule, which is n times x to the n minus 1. That's the quickest way to get rid of the polynomials, right? And then again, in a way, you're still using the sum and difference rule, right? When you guys have the pluses and the minus right there. Okay, so keep that in mind too. It's just like do it separately, take it step by step, and it's going to be the fastest and easiest way to do this. And then again, so the other day we did talk about pretty much like how to expand. We have f of x equals x minus 3 to the third power. So I did show you guys how to expand these using the Pascal's triangle, right? So if you remember how to generate it, you would go down pretty much to the fourth row, I think. And that pretty much has, so you're going to have 1 times x, and then plus, that's going to be 3 times x to the second power times negative 3, and then plus 3 again times x to the first power times negative 3 to the second power, and then finally plus the last 1 times the last value cubed, which would be negative 3 to the third power. All right, I did miss a cube here at the beginning. All right, so again, we simplify. We're still doing pretty much, we're still at x minus 3 to the third power. So here we have x to the third, and then we have 3 times negative 3 gives us negative 9x squared. 3 times, first we do this part, that would give us positive 9. So that would be plus 27x, and then plus 1 times negative 3 to the third power, that would be negative 27. And then again, so that's pretty much still f of x. We still want to find f prime of x, and that's going to be our next step. So f prime of x. So again, this is just to get you guys used to doing it a lot quicker, right? We're applying the power rule again. So n is 3, so that gives us 3 times x to the second power, and then negative 9 times 2, right, which is our n, and then x times to the first power, and then again, there's a constant here, 27, so plus 27. The derivative of x is always 1, and then minus the derivative of a constant, which is 0. So just keep that in mind, all right? It's always 0. Derivative of a constant is always 0. So here we're going to have, we simplify again, so you're going to get 3x squared minus 18x plus 27. And that's pretty much going to be our f prime of x. And then in example D. So we pretty much have our g of x equals 2x squared minus 3x all over the square root of x. So again, as a reminder, if you guys see a single fraction, make sure you guys split it up so it makes it a lot easier for you guys to simplify, right? Divide out the x's and then apply the power rule. So again, make sure you pick up those little shortcuts, right? So here, for sure, the simplest way to go about this is to separate them. So it's going to be 2x squared over x to the 1/2. So I'm already rewriting that square root as a exponent. And then minus 3x over x to the 1/2. So here, what you guys want to do is, again, one more time, we want to simplify the exponents, right? Basic properties of exponents. 2 minus 1/2 gives us 2 times x to the 1/2. And then minus 1 minus 1/2, so that's going to be minus 3 times x to the 1/2. Actually, this one's 3/2, I'm sorry, the first one. And now again, this is g of x, and now that I have that, right, everything is nice in the way that I want it to be, in n times x to the n minus 1 format. So here, we want to find g prime, so g prime of x. Again, constant is 2, and then our n is 3/2, so 3 over 2. And then take away 1 from this, so 3/2 minus 2 halves, it gives us 1 half. And then our next constant is -3. And then x 1 half minus 1 gives us -1 half. And then again, simplify one more time. So this would be our g prime now. Divide those out, and then we have 3 times x to the 1 half, and then -3, and then, oh, I did miss something here, actually. I missed that I didn't multiply by 1 half right there. So that's going to be 3 halves right here. And then x to the -1 half gives us x to the 1 half. All right. So sorry about that mistake right there. Forgot to put in my n. I did subtract. I just forgot to put in my n. So that's pretty much going to be our g prime of x.